Now, we all know that all planets are round. There are no square ones so far, and that's because of gravity. Well, roundish at least, as not all of the planets have perfect proportions. But did you ever wonder about the shape of the universe itself? Is it also round because of the same forces? Well, not really. Based on what information we have so far, the universe is actually flat? According to the principles of general relativity, space has the ability to curve. This opens the door for the universe to have three potential shapes: a flat plane like a sheet of paper, a closed sphere like a bowl, or an open saddle-like curve. This isn't just a matter of academic interest, you know. The universe's shape has direct consequences on its ultimate destiny. One cosmologist from Princeton University explained it beautifully. The shape of the universe is a kind of map to its past and a predictor of its future. The questions of whether the universe will keep expanding forever or collapse at some point, and if it's finite or infinite, all circle back to the question of its shape. Now, to wrap your head around this cosmic question, you need to understand two key elements: the density of the universe and its rate of expansion. Let's dig into this a little. Around 68% of the universe is made up of dark energy, while 27% is dark matter. The rest, which is normal matter, if you'd like, makes up the stars, planets, and other cosmic bodies we're familiar with. When we talk about the density of the universe, we're referring to the quantity of normal matter packed into a given volume of space. Now, if the universe is denser, it also has more gravity. In this case, the gravitational pull can overcome the force of expansion, so the universe curls up into a sphere. This shape is known as the closed model, where the universe ends up looking like a gigantic cosmic ball. Imagine a world that's finite but without boundaries, a contradiction for sure. In this model, an adventurous explorer could travel forever through space, never bumping into a wall or falling over an edge. Alternatively, if the density of the universe is low and not enough to halt the expansion, then space distorts in the opposite direction. This results in an open universe with negative curvature that resembles a saddle, like on a horse. Despite these two potential scenarios, most scientists agree that the density of the universe is just right, which means it expands proportionally without curving. But what does it mean if the universe is flat? It doesn't mean we're living in an infinite sheet of paper. To understand it, consider these analogies. Imagine you're in a square room, walk 10 steps to the next corner, make a 90-degree turn, walk another 10 steps, and repeat this process twice more. You end up back at your starting point, completing a square. Add another dimension to this geometry, since we're not 2D creatures, and whoopee, you have a flat universe. This analogy wouldn't hold up in a curved space. If you have a terrestrial globe at home, you might find it easier to understand this next experiment. Start by placing your finger at the Earth's equator, then trace a line to the North Pole, make a 90-degree turn, and return to the equator. Make one more 90-degree turn and walk back to your starting point. This journey only needed 3 turns, unlike the 4 turns in the flat universe scenario. Still struggling to understand? Here's another way to picture it. In a flat universe, 2 rockets traveling side by side will always remain parallel. This is in contrast to a closed universe, where the rockets will travel along the curve of space and eventually meet where they started. In an open universe with negative curvature, the rockets will gradually drift apart and never cross paths again. So, is there a cosmological crisis at hand? It seems the answer to the shape of our universe is encoded in the cosmic microwave background, also named CMB, which is like the universe's fossil record. Over the past few decades, scientists have measured temperature fluctuations in the CMB to find almost no curvature, indicating a flat universe. Now, the concept of a flat universe is crucial to the standard cosmological model. However, in late 2019, scientists from a university in Rome published a paper arguing that current CMB measurements actually indicate we're really living in a closed universe. How did they figure this out? Well, they looked at how light behaves in the universe. Specifically, they analyzed how light bends because of the gravitational force of matter in its path. Either way, apart from this finding, there's nothing else that would suggest we're living in a closed universe. Most scientists believe this recent discovery is nothing more than a statistical anomaly. But if the closed universe theory turns out to be right, it would shift decades of astronomical findings. If the universe is indeed curved, it must be so large that the observable 93 billion light-years aren't enough to reveal its curvature. It could be similar to standing in a fog, only able to see a small, flat patch of land. Yet somewhere out of sight, the horizon reveals that we live on a sphere. As we continue to probe the cosmos, we might find that the apparent flatness of our universe is just a small part of a much larger, curved cosmos. Its shape is just one of the many things we've yet to figure out about the universe. We can't quite put our finger on why the universe is even here, for instance. We do have some theories, but scientists are yet to be sure. It could be that the universe is like a pop-up, materializing out of an unstable nowhere land. Imagine the emptiest emptiness you can think of, suddenly churning out matter and energy in equal and opposite amounts that tally up to zero. For most of us, it's hard to picture that process. If we follow this theory, who's to say there's only one universe? We might be just one of an enormous collection, a so-called multiverse. For now, we'll just have to wait for the next wave of cosmic measurements to refine our theories, and for scientists to come up with hypotheses that aren't just mathematically pretty, but actually testable. Also, how could we possibly know all the secrets of the universe if we don't completely understand our own biology yet? I mean, if we did, we could, theoretically, solve all of our health problems, right? We might even be able to play around with our DNA, like this molecular Lego, and give ourselves naturally purple hair or red fingernails. Well, time for a reality check, as we're still struggling with this one too. Here's a great example: our microbiome. Our bodies, home to 10 trillion human cells, are also an active city for 100 trillion microbial cells. That's a couple of pounds of bacteria and other microbes, which we absolutely can't do without. They've set up shop in our bellies, lungs, noses, and every other hidden nook and cranny. We're like luxurious cruise ships for these tiny microbial tourists, and we still don't fully understand the implications of this symbiotic relationship. There are still a lot of things we don't know about planet Earth either. We've only ever dipped our toes into Earth's crust, never venturing more than a few miles deep. Everything else is our best guess, from remote sensing and smart physics. Believe it or not, it took us an embarrassingly long time to accept that the Earth's crust is constantly shifting, like Jenga pieces. We only warmed up to plate tectonics in the mid-20th century. We're also still trying to figure out precisely how the planet's inner engine works, and how the swirling conducting materials in the outer core create our protective magnetic field. Plus, with 4.5 billion years of geological chaos, we're sometimes better off studying meteorites or the surfaces of other celestial bodies for clues about our planet's history. Even our faithful companion, the Moon, is a bit of a mystery. Was it born from a colossal collision or some other event? We're still not sure. But hey, the fact that we still have a lot to learn is what makes life interesting, isn't it? That, and the thrill of actually finding an empty parking spot in San Francisco, or maybe even your city.
Have you ever heard about the Big Bang? I bet you have. So the history of the universe and its evolution is widely known as the Big Bang model. It claims that our universe began as an insanely hot and dense speck about 13.7 billion years ago. But how did it go all the way from a tiny point to the ginormous world we see and don't see today? We're about to figure that out. Despite its name, the Big Bang wasn't a powerful space explosion. It was the appearance of space everywhere in the universe at once. And the universe itself was born as a very dense single spot in space. No one knows for sure what was before this moment, but scientists are working on figuring it out. Their main assistant is the cosmic microwave background, which still contains the afterglow of the radiation and light left after the Big Bang. Eventually, it may help scientists piece together some clues about the early universe. Just like any kid, when the universe was very young, about 100th of a billionth of a trillionth of a trillionth of a second, it experienced an unbelievable growth spurt. Known as inflation, this burst allowed the universe to double in size at least 90 times. As the universe was expanding, it was also getting cooler and less dense. After the insane growth burst, it kept growing, but at a much slower rate. Very soon, the universe cooled down enough for matter to start forming. Everything happened so fast at that time. Light chemical elements appeared within the first 3 minutes after the formation of the universe. Protons and neutrons began to collide, producing deuterium, an isotope of hydrogen. A lot of this deuterium combined and created helium. Then, the process is slowed down significantly, but still for the first 380,000 years after the Big Bang, the intense heat from the creation of the universe made it too hot even for light to shine. The conditions in this early universe were hellish. Atoms collided with such force that they broke into an opaque plasma of electrons, protons, and neutrons. This dense veil scattered light like fog. But 380,000 years after the Big Bang, the matter eventually cooled down enough for electrons to connect with nuclei and form neutral atoms. This absorption of free electrons finally made the universe transparent. By the way, the light unleashed at that time can still be detected today in the form of radiation. A period of darkness followed this era called the Era of Recombination. And then, stars and other bright objects started to form. It happened about 400 million years after the Big Bang. This next period got the name reionization. Some time ago, scientists thought that it had lasted more than 500 million years, but new evidence hints that it might have occurred more rapidly than we thought. During this period, clumps of gas collided and created the first galaxies and stars. These events emitted ultraviolet light, which got rid of most of the surrounding neutral hydrogen gas. That's why we call those times the period of reionization. This process led to the universe becoming transparent to ultraviolet light for the first time. At the moment, astronomers are combing the universe in search of the farthest and oldest galaxies. Such a discovery can help us understand the properties of the early universe. It's like working backwards to piece together the events that happened before. That's what researchers are doing now by studying the cosmic microwave background. Our solar system was born around 9 billion years after the Big Bang, which makes it around 4.6 billion years old. As far as we know, our Sun, orbiting approximately 25,000 light-years from the galactic center, is one of more than 100 billion stars in our home Milky Way galaxy. The most popular idea is that the Sun, as well as the rest of our solar system, was once formed from a huge rotating cloud of space dust and gas known as a nebula. At one point, gravity caused this nebula to collapse. It started spinning faster and, eventually, flattened into a disk. Most of the material that made up the nebula got pulled towards the center of this formation, and that's how the Sun was born. At one point, scientists started thinking that there might be more mass in the universe than what we see. After some research, the concept of dark matter appeared. One theory stated that this mysterious stuff could be formed by some exotic particles. They don't interact with regular matter or light. That's why it's so difficult to detect them. Already in the 1920s, astronomers made an astounding discovery. Apparently, the universe isn't static. It's constantly expanding. Interestingly, when decades later, in 1998, the Hubble Space Telescope studied distant supernova, it became obvious that in the past, the universe was expanding more slowly than today. Why was this discovery so confusing? because it was long believed that the gravity of matter making up the universe would slow down the expansion process, or even cause the universe to contract. That's why these days the concept has changed a bit. Everything on Earth and everything people have managed to see in space with the help of telescopes and other instruments is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Around 27% of the universe is dark matter, and almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if, several decades ago, they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite, it was accelerating. It meant that there had to be some enigmatic force counteracting gravity. It got dubbed dark energy. The European Space Agency's Planck satellite helped astronomers calculate how much dark energy the universe has to contain to explain the way its expansion is constantly speeding up. Scientists have also built models of how many giant stars formed and collapsed into black holes since the beginning of the universe. The conclusion is very exciting. The vacuum energy in these black holes is almost the same as the amount of dark energy that should exist in the universe. And still, even though nowadays we know much more about the universe than we used to, there are still important questions that remain unanswered. And of course, dark matter and dark energy remain the biggest mysteries. Another one is whether something existed before the universe was born, or maybe the theory of the false vacuum is correct. It says that our universe exists in a false phase state, which means it's just a temporary thing. What's more, it's only part of a larger universe. If you compare this larger universe with a kettle full of boiling water, the universe we live in will be just a tiny bubble on the surface of the water. But this can't keep going endlessly. One day, perhaps in billions of years, this false vacuum will burst. And then the visible universe around us will instantly vanish with a pop. There won't be any preliminary warning, and we'll have to somehow deal with it. In any case, astronomers are working hard to find the answers to these burning questions. The James Webb Telescope, launched in 2021, is believed to be the very tool that can help us to peer back to the beginning of time and explore the evolution of the universe with the help of its infrared instruments. By observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that formed in the early universe. To look that far back in time, we need to look deeper into space. All because it takes light time to travel from there to us. So the farther we look, the further we glimpse back in time. To find the first galaxies, James Webb is going to make an ultra-deep near-infrared survey of the universe. The Big Bang Theory doesn't explain how exactly our cosmos started. It's more like a story about what happened after, in the earliest stages of the universe. That's when all stars, galaxies, and specks of dust were crammed into a dot, no bigger than a peach with a temperature of more than 1 trillion degrees. Our cosmos doesn't have an edge or outside. The Big Bang wasn't an explosion that happened at some particular point. It was the moment when space itself began to expand everywhere at the same time. That's a process we call inflation. When the cosmos was nearly 1 million times smaller than today, everything was just a plasma that later expanded, cooled, and then converted into a neutral gas. That was the time when the first atoms formed. All these processes released enormous amounts of radiation. The cosmic microwave background, CMB, is the fossil of that radiation that dates back to about 380,000 years after the Big Bang. Before that, the heat from the creation of the universe was way too intense for even light to shine. Only after matter cooled down did it get lighter because the universe became less dense and more transparent. In the first 3 minutes of this process, certain light elements formed, such as hydrogen and helium. About About 400 million years after the Big Bang, the cosmos slowly started coming out of its dark ages. This period probably lasted over 500 million years. Clumps of gas came together and formed something beautiful, the very first stars and galaxies. All this gave off lots of ultraviolet light. It was as if someone finally turned on a cosmic flashlight that cleared away the foggy gas that was all around. About 9 billion years later, our solar system got into the game too. It was born from this dense cloud of interstellar dust and gas. The cloud fell apart, possibly because of the shockwave produced by a star that exploded somewhere nearby in a spectacular supernova. This left us with a solar nebula, a disk of material that kept spinning. At its center, gravitational forces kept pulling more and more material in. At one moment, the pressure at the core became so great that hydrogen atoms started to mix and form helium. Like it happens with other processes in space, this released giant amounts of energy. And ta-da, we got our star. So big that it makes up over 90% of all the matter in our solar system. The remaining matter from the disk had its own job to do. It probably started off as grains of dust even smaller than the width of your hair. Gravity and other forces made clumps smash into one another. They got bigger and bigger. Particles of dust eventually evolved into pebbles, and then, as this donut-shaped disk of gas kept spinning, they turned into rocks. Meanwhile, the star pulled in nearby gas and pushed the rest of the material farther away. Those parts of the disk were far away from the sun, so water in those regions started to freeze. Soon, there were tiny pieces of ice flying around, gathering into dirty snowballs that became planetary cores. Since it was cold, gas molecules could slow down enough for a planet to draw them closer. That's how we got our famous gas giants, Neptune, Uranus, Saturn, and Jupiter. Jupiter and Saturn probably formed first, maybe even within the first 10 million years of the existence of our solar system. Parts of the disk that were closer to the sun remained warm. The material there gathered into rocky planets. After the icy giants appeared, not much gas was left for the other ones though. So, Mercury, Venus, Earth, and Mars ended up a bit smaller. They may have taken tens of millions of years to form after the sun was born. This is, of course, a very simplified version of how we got 8 planets in our solar system. Who knows if we'll ever know the whole truth? Time went on. Space debris was swirling around. Some objects became large enough for their gravitational force to shape them into spheres. That's how we got dwarf planets and big moons. Our asteroid belt is the region that separates inner planets from outer ones. It's full of pieces and bits from the early solar system that never grew into something bigger. They just kept on floating around, maybe waiting for another chance. Other smaller leftovers turned into comets, meteoroids, asteroids, and small irregular moons. 4.5 billion years ago, something else arose from all that chaos. A planet almost as big as Mars collided with Earth. And the debris formed the only moon we have today. Somewhere around that time, the Sun also got to a new level. At its younger stages, it was just a ball of helium and hydrogen that still wasn't powered by fusion. Over millions of years, it got hotter and more pressurized, and finally turned into the shining star we know today. It's supposed to stay like this for a very, very long time. Around 10 billion years. Simulations scientists have made to understand the creation of the universe show that the chaos of that time was even bigger than we thought. Orbits of the giant planets probably shifted during that period too. The gravitational force from many objects in the Kuiper Belt shook Saturn and Jupiter into a 2-1 resonance. That means Jupiter made a circle around the Sun twice for every Saturn orbit. This brought the two giants closer together, which wasn't good for their surroundings. There's a theory that Uranus didn't form where it is today, which is 20 times farther from our Sun than Earth. At this distance, there wasn't enough material to make the whole planet. That's why there's an idea that Uranus was born closer to the Sun before it got ejected farther away for some reason. Maybe that reason was the mess Jupiter and Saturn made. Some believe Neptune shares a similar destiny, together with the whole Kuiper Belt. As Uranus and Neptune were passing through the Kuiper Belt, they scattered most of the objects there. Any additional ice planets that had formed there also ended up kicked out, but in this case, entirely out of our solar system. Pieces of these scattered worlds that were located more outwardly stayed in the Kuiper Belt and the Oort cloud, a faraway sphere of ice bodies where the majority of comets come from. In all this chaos, the inner planets got hit. Scientists think that's how we got organics and water here on Earth. That's exactly what we needed for life to start developing, somewhere 3.8 to 3.5 billion years ago. We found evidence of microbes in the hard structures they made. Those are called stromatolites. They help us understand the earliest forms of life on Earth. Up until 3 billion years ago, Mars might have also been a good place for life. The red planet used to have a thick atmosphere and a strong magnetic field, just like Earth. But unlike our planet, Mars cooled from the inside, which switched off this whole mechanism. Without its magnetic field, nothing could protect the planet from the solar wind that pulled away most of its atmosphere in just a few 100 million years. Mars used to have magnificent lakes, rivers, and water streams that left traces we can see on its surface, even today. Luckily, Earth managed to keep its water, so life continued to evolve. 2.5 billion years ago, Earth got photosynthetic organisms that started pumping oxygen into the atmosphere and helped create the entire animal and plant kingdom across the planet. Another big thing happened in our solar system later. Saturn got its astonishing rings. No one knows for sure what happened back then, but a new theory says the rings aren't as old as the planet itself, only about 100 million years old. At the same time, something hit our moon and left Tycho crater, one of the most prominent craters on the lunar surface. Other planets couldn't avoid collisions either, including Earth. You already know what happened 66 million years ago. A giant asteroid triggered changes in climate and erased 3/4 of life, including dinosaurs.
What will the end of the universe be like? It might be 100 billion years away. But here's the real question. Should we start panicking already? Jan Levin, a cosmologist, appeared at a recent screening of the captivating Netflix documentary, A Trip to Infinity. She mentioned that there would be a time when the last sentient being exists and the last flicker of thought fades away. This perspective sheds a whole new light on things. Somewhere in the vast expanse of the universe, there will be a moment when the memories of legends like Einstein and Elvis will fade away. Just imagine what that last thought would be. A brilliant pearl of wisdom, a colorful expletive. The possibilities are as endless as the stars in the night sky. Now let's take a cosmic detour and explore how we got ourselves into this peculiar predicament. As we currently understand it, our universe burst into existence with a bang approximately 13.8 billion years ago. Since then, it has been expanding at an ever-increasing pace. For decades, astronomers debated whether this expansion would continue indefinitely or if a big crunch awaited us in the distant future, where everything would collapse back together. Everything changed in 1998 when astronomers stumbled upon a discovery. The cosmic expansion was accelerating. This turbocharged expansion was fueled by a mysterious force called dark energy, woven into space-time's very fabric. The larger the universe grows, the more this enigmatic force pushes it apart. It's eerily similar to the cosmological constant, a concept introduced by Einstein to explain why the universe didn't collapse, only to be discarded later as a blunder. But guess what? The cosmological constant turned out to be a stubborn idea that refused to fade away. And now it poses a threat to both physics and the universe itself. If dark energy triumphs in the end, distant galaxies will eventually speed away from us so rapidly that we won't be able to see them anymore. With each passing moment, our understanding of the universe will diminish. Stars will extinguish and never ignite again. It will be akin to living inside an inverted black hole where matter, energy, and information are swallowed beyond the event horizon, lost forever. The star-making days of our universe are behind us. Star formation reached its peak nearly 10 billion years ago and has been gradually declining ever since. The reason for this waning of stellar light is our expanding universe. As the cosmos grows larger with each passing day, the matter within it remains constant but gets spread out over more and more volume. To create a star, matter must be compressed into relatively small volumes. As the universe ages, fewer opportunities arise for such compression. So, in the far future, we can estimate that the last star will be born approximately 1 trillion years from now. This final star is likely to be a small red dwarf, a fraction of the mass of our Sun. Red dwarf stars have extraordinarily long lives, slowly burning through hydrogen in a steady fusion reaction, but eventually, even they will exhaust their fuel. In roughly 100 trillion years, the last flicker of stellar light will fade away. This accelerated expansion will progressively limit our view of the wider universe. Although we can still observe distant galaxies because of the light they emitted long ago, their current light will never reach us. As the universe expands at an increasing rate, the boundary beyond which galaxies recede from our view moves closer and closer. One by one, galaxies will be torn away from us by the relentless cosmic expansion, accelerating so swiftly that their light will forever elude us. Anything not gravitationally bound to us will be unable to withstand this onslaught. Only the local group, consisting of the Milky Way, Andromeda, Triangulum galaxies, and several satellite dwarf galaxies, will remain in our proximity. However, this lingering existence will be far from idyllic. Over time, our 3 galaxies will merge into one megagalaxy, completely isolated from everything else in the universe. In this solitary state, the megagalaxy will slowly dissolve. Chance interactions will scatter individual stars, or what remains of them, into random orbits. Some will be hurled into the giant black hole at the center of the galaxy, while others will escape into the void, never to be seen again. After an unimaginable span, no complex systems will endure. All that will be left are isolated islands drifting in an infinite expanse of darkness. To make matters worse, as thinking requires energy, there will eventually come a time when the universe lacks the energy to sustain a single thought. Eventually, all that will remain are subatomic particles, dancing in the vast expanse of intergalactic space, engulfed by eternal darkness. This will occur trillions upon trillions of years after the last glimmers of light and life have vanished. And then, countless eons will stretch onward to the point where even measuring the passage of time becomes impossible. As Brian Greene described it in his book, Until the End of Time, it's a tale full of sound and fury, signifying nothing. This might make us feel some sort of weight of insignificance in the face of this cosmic destiny. If this truly is the fate awaiting the universe, it's both humbling and disheartening. Our universe may be 14 billion years old, but that's just a fleeting moment compared to the unfathomable darkness that lies ahead. It means that everything remarkable in our universe occurred in a mere blink at the beginning, followed by an eternity of emptiness, its finality and futility on an unimaginable scale. But hold on a second. Before we surrender to despair, let's remember that we're still a long way from this inevitable end. New discoveries in physics could provide a glimmer of hope, an escape hatch from this fate. Perhaps dark energy is not constant. Maybe it will change its course and bring the universe back together. Michael Turner, the brilliant cosmologist who coined the term dark energy, emphasized that the cosmological constant would be the least interesting answer to the dark energy puzzle. So, who knows what surprises the future holds? But for now, we can't help but peer into the abyss and wonder. We are but brief inhabitants of this cosmic spectacle, here for the grand party when the universe brims with life and light. We may not have a say in the final act, but we can cherish the here and now, reveling in the magic of the present. As astrophysicist and philosopher John Archibald Wheeler once said, the past and the future are mere fictions, existing only in the artifacts and imaginations of the present. From that perspective, the universe ends with each of us, granting us a unique perspective and a chance to make our mark. So let's embrace the fleeting nature of existence. Though the future may be finite, it liberates us to fully appreciate the wonders of this moment. After all, as the saying goes, nothing lasts forever, whether it's the stock market, the stars, or even our own lives. An awareness of eternity's whiff can illuminate the brilliance of a lifetime, even if it's just mine or yours. There is more than one theory about how the universe is going to be gone forever. In the world of quantum field theory, for example, we come across something called a vacuum decay. Picture it as a vacuum that's kind of stable, but not totally rock-solid stable. This false vacuum can hang around for quite a while, chilling in its semi-stable state. Could eventually say, nah, I'm done, and transform into a more stable vacuum. We call this wild event false vacuum decay. It's like a cosmic game of Jenga, where the unstable blocks finally collapse, and the universe finds its true balance. So, cosmic adventurers, let's treasure the Milky Way and all its splendor for as long as it lasts. And who knows, maybe in the vastness of this ever-expanding universe, there's still a surprise or two waiting for us. The story isn't over yet, and the cosmos is filled with secrets waiting to be uncovered. What do you think the end of the universe looks like for us humans? Are we even going to be around to witness it?
NASA has recently revealed some eerie cosmic sounds that go against the popular misconception about the muteness of space. This discovery proves once again that the universe is far from silent. The revelation came from the Perseus galaxy cluster, located 250 million light-years away from Earth. There, NASA uncovered an unworldly howling coming from the supermassive black hole at its center. This discovery isn't super fresh. It was made in 2003. It marked the first time scientists detected an acoustic phenomenon from such a distant source. Sadly, the sound was not something you would be able to hear. Its frequency was just too low for the human ear to register. The lowest pitch the human ear can perceive is 20 Hz, 20 cycles per second. But the sound emitted by the black hole is a B-flat, 57 octaves below middle C, with a frequency of 10 million years. But NASA brought it to the realm of human hearing in 2022, turning that invisible sound into something you could actually experience. It was a breakthrough of cosmic proportions when NASA revealed that sound waves could travel through space, specifically through the medium of the Perseus galaxy cluster. This medium is a hot, dense gas, something far more substantial than the empty vacuum between galaxies. That's how sound waves manage to travel there. Those sound waves produced by the supermassive black hole at the center of Perseus resonate through the hot gas as ripples. It's like how sound travels through water here on Earth. The thing is, space is indeed a vacuum, which means that sound cannot travel through it, in the traditional sense. But the gas surrounding the black hole in Perseus provided the perfect environment for sound to travel. The black hole's powerful jets create ripples, sending vibrations through the gas. And NASA scientists have identified those vibrations as a type of cosmic sound. Previously, it was totally invisible and unhearable. But now, for the first time, astronomers have helped it to take a form humans can hear. To give us a sense of how deep this sound is, NASA raised its pitch by 57 octaves so that it could finally be audible to the human ear. The result is a haunting, bass-heavy hum. It feels as though it is resonating from the very core of space itself. What NASA did is called sonification. This process involves mapping the characteristics of the data to audible sound. As a result, we can experience something that is otherwise beyond our perception. See those brighter areas of the cluster? They produce louder and higher-pitched tones. The sonification of the Perseus black hole isn't just a scientific discovery. It has allowed us to see, or should I say, hear, the universe in a completely different way. NASA has used this technique on several different space objects, including stars, nebulae, and galaxies, giving us a glimpse into the various ways space can sound. One of the coolest NASA's sonifications is Cassiopeia A. It's the remains of a star spotted as a supernova more than 300 years ago. Located around 10,000 light-years away from Earth, this shattered remnant of a once massive star has a neutron star at its core. And it's the youngest neutron star in our galaxy that we know about. To perform the sonification of Cassiopeia A, NASA took the data captured by the Chandra X-ray Observatory and translated it into sound. Starting at the center, a triangle-shaped tone marks the location of the neutron star. Then, the sound spreads outward, which represents the expanding debris field. That's when the pitch rises and the tones become brighter. The sound grows louder and seems to mirror the outbursts of the supernova and the formation of new elements. The Tarantula Nebula, located in the Large Magellanic Cloud, is a hotbed of star formation and one of the most active regions in the universe. Astronomers have been studying this nebula for a long time to learn more about how stars are born and evolve. So, no wonder that NASA scientists have been doing their best to translate the data from the nebula into sound. They've been mapping brightness and pitch to various features in the nebula. So, airy, synthesizer-like tones represent the chaotic and hot gases surrounding the most massive stars. And the cooler gases that are forming new stars have soft, low notes. Piano-like tones correspond to the brightest stars. And the central cluster of stars sounds like a rain stick. Interestingly, NASA's investigation into the sounds of space doesn't just involve cosmic phenomena. It's also based on the experiences of astronauts, and some of them are truly eerie. After all, space exploration is always filled with unexpected surprises, and sometimes those surprises come in the form of strange noises aboard spacecraft. One such incident occurred aboard the International Space Station, when astronaut Butch Wilmore reported hearing a strange noise coming from Boeing's Starliner spacecraft. By that time, this spaceship had been docked at the station for almost 3 months. The Starliner had just completed an 8-day mission that went awry. The technical issues have been plaguing the spacecraft ever since. Wilmore described the sound as a pulsing noise, similar to a sonar ping. It was coming through the spacecraft's speaker system. This strange noise made Wilmore contact NASA's Johnson Space Center in Houston. Of course, Mission Control immediately began investigating. They were able to listen to the audio inside the Starliner. Wilmore even held his microphone up to the speaker so that NASA could hear it more clearly. The people in charge of the investigation finally identified the source of the noise. They announced there was an audio configuration issue with the ISS's complex communication system. The thing is, this system connects numerous spacecraft and modules, and such configurations can sometimes lead to strange noises. NASA reassured everyone that such an issue wasn't really unusual. At the same time, they encourage astronauts to report any unexpected sounds they come across. At the same time, this incident was just another proof of how tricky it is to maintain advanced spacecraft systems in orbit. The Starliner had already faced serious delays and setbacks. And every new issue added extra pressure. Everyone was worried about the spacecraft's safe return to Earth. In any case, it's not the only incident involving eerie space sounds. In 1969, during the Apollo 10 mission, astronauts heard something truly bizarre while orbiting the Moon. Now, Apollo 10 was a dry run for the historic Apollo 11 moon landing. This mission involved astronauts Thomas Stafford, John Young, and Eugene Cernan. They were testing the systems of the lunar module. Everything was going smoothly, and then they started passing behind the Moon. In that region, radio signals from Earth couldn't reach them. At that point, they all started hearing a strange, high-pitched whistling sound. It was coming through their headsets. The origin of this noise baffled the astronauts since it wasn't supposed to exist in the near vacuum of space. At first, they simply joked that it sounded like outer space music. But in reality, the situation was quite unnerving. The astronauts were on the dark side of the Moon, far away from Earth and any help. And now there was also that eerie, mysterious sound they couldn't explain. At the same time, NASA was super worried about astronauts' health and mental condition. So the crew didn't immediately report the noise to Mission Control. But after they returned to Earth, NASA engineers thoroughly investigated the phenomenon. They came to the conclusion that the sound had most likely come from the spacecraft's communications system. The reason could be the unusual circumstances of the mission. After all, the spacecraft was kinda cut off Earth. The Moon was between it and our planet. Still, even after this extensive analysis, the origin and nature of the whistle is still a great mystery for many people. Anyway, all these new discoveries and old cosmic puzzles prove that the universe is far from silent. It hums, roars, whispers, and reveals the mysteries of the cosmos one note at a time. In the future, as our technological abilities continue to evolve, NASA's work with sonification and its study of strange astronaut experiences will likely lead to even more awesome discoveries. And if we listen more closely, we may find that the universe is much more talkative than we think.
Imagine if somewhere, trillions of light years away from our world, there's another version of you watching this very video right now. Not as crazy as it might sound. The multiverse theory is having its time of the day, from Marvel's movies to Spider-Verses to the recent famous hit Everything Everywhere All at Once. But it's not just some wild sci-fi concept. Physicists have been talking about this theory for decades. Let's see what they say. Do parallel worlds exist? If they do, let's hope that this is the reality where you click that subscribe button before diving into the video. Now, everything starts with the Big Bang. Before the Big Bang, the universe, with everything we know, was crammed into an unbelievably tiny, super hot, and mega-dense point. Our universe is about to burst into existence. And then, boom! The most colossal event you can imagine happens. In an instant, this tiny point expands with indescribable speed. It's the beginning of everything – time, space, and all the galaxies that surround us. Then, like an extremely hot balloon, the universe started stretching out in all directions, which sounds logical, but what's curious is that this inflationary epoch lasted for an incredibly brief time, in less than a blink of an eye. It's like the universe hit the fast-forward button and then everything eventually slowing down over time. After this speedy phase, the universe kept growing, but at a more normal pace. This rapid expansion is called inflationary cosmology. It explains some big mysteries about our world. It tells us why it looks the same in all directions, why the background radiation is evenly spread, why galaxies are where they are, and so on. The details of how this cosmic inflation works are still a bit mysterious, but scientists are on it, and the theory itself is universally accepted. But it wasn't always this way. To scientists, this idea sounded like insane sci-fi at first. However, it explains so many things that the scientists just had no choice but pay attention to it. However, its initial weirdness was just the beginning. Now, according to this theory, inflation might not be a one-time thing. It could be happening repeatedly, maybe even endlessly. Picture the universe as a never-ending cycle, with each burst of inflation creating its own bubble universe. And the most important thing is that these bubble universes might not play by the same rules. Some could be totally weird, where the laws of physics are going crazy in ways we can't even fathom. Which means there might be a whole constellation of bubble universes out there. However, we can't directly see these other bubbles. They exist beyond the edge of our spotlight. That's where the multiverse theory comes into play. People have been chatting about the idea of multiple universes for a long time, like way back in ancient Greece. Now, back in the 1990s, people got really interested in this idea, and this concept started popping up in books and movies. As a result, scientists began talking about it increasingly in scientific discussions and journal articles. And nowadays, many scientists and philosophers are into it. Now, the problem is, there's no solid proof or evidence that these other universes really exist. It's not a proved or confirmed theory. It's not even a theory at all, just a hypothesis, a bunch of interesting thoughts put together. Before we draw any conclusions, we need much more in the way of clues and evidence, and unfortunately, it's hard to find the evidence of parallel worlds when we can't live or look past our own, which is why many scientists believe that it might not be real. But not everybody agrees with that. While critics say that we can't observe the multiverse, and therefore can't test it, some physicists suggest a different approach. Instead of trying to find these parallel worlds, we could try to look at ours and its history. Around the 2010s, researchers took a closer look at data from a space gadget called the Wilkinson Microwave Anisotropy Probe. Yes, that's a mouthful. They thought they found signs suggesting that our universe might have bumped into other universes in the past, like sort of a collision. But then scientists used an even fancier satellite, which had 3 times better resolution, looked at the data more thoroughly, and didn't find any strong proof of these universe collisions. Plus, there was no evidence that other universes were tugging on ours with their gravity. However, an interesting discovery happened in 2015. One scientist checked out radiation left over from the Big Bang. He claimed to see something super bright, 4,500 times brighter than expected. Well, at least based on the stuff, like protons and electrons, scientists think existed in the early universe. So he and some others assumed that this might be our first evidence of our universe crashing into others. But let's assume that it does exist. The multiverse wouldn't be about human decisions creating alternate timelines. In quantum mechanics, it's not human decisions that split everything into parallel worlds, but the measurement of subatomic particles. So if we look at this theory scientifically, other worlds would be billions of light years away, and what's happening to them wouldn't have anything to do with our daily choices. So what would it look like? Well, Max Tegmark, for example, talks about 4 levels of universes and multiverses. Level 1 is the extension of our world. Our universe is a big place, and in an infinite universe, there would be infinite chunks like ours, each with its own story. Most of these chunks might look different from ours, but because there are so many, some might look just like ours, but they'd be really, really far away. Level 2 is a universe with different physical constants. This idea says that our universe is part of a much bigger space where bubbles form. Each bubble might have its own set of rules, like different laws of physics. Level 3 is the many worlds interpretation of quantum mechanics. This one's a bit tricky. In the quantum world, things can be weird. Imagine rolling a dice. Each number that comes up might create a separate universe. So if you rolled a dice and got a 3, in another universe, it would be a 6, and so on. Yeah, my head's spinning. This idea suggests that every possible outcome in quantum events creates a whole new universe. And level 4 is the ultimate ensemble. This level gets super abstract. It says that everything, every possible universe or reality, can be described using math. I wish now I hadn't fallen asleep in algebra. Imagine all the different math equations describing every conceivable way the universe could be. This level says that every math equation that can describe a universe actually exists, and they're all real in their own way. Stephen Hawking was a proponent of the Level 3 many worlds interpretation. It was one of his last theories before he passed away. He predicted that the universe is finite and far simpler than many current theories about the Big Bang say. According to Hawking, the universe is like a giant quantum system, a sea of possibilities and probabilities. In this view, every outcome of the universe's history plays out in parallel existences, and we, as observers, play a crucial role. Our existence and what we observe, according to Hawking, actively shapes the universe we see. In simple words, the universe is a canvas and we're all painters. Sounds very cool and insane, but hey, many things in science were considered crazy before they turned out to be true. So, is there another copy of you somewhere watching this video and who just pressed the like button? Who knows? If there are infinite copies of us, scientists assume that we might be like identical twins, sharing the same origins and starting from one thing, but then developing into separate different people. And if these worlds exist, perhaps we could even visit them one day. There could be some connections between us, something that could allow for interdimensional travel. For example, wormholes. Well, whatever the truth may be, let's hope that one day we'll discover it. Until then, stay curious. Back in 2008, astronomers found a mysterious something orbiting a star called Fomalhaut. This star is very bright and sits about 25 light-years away from us. Trillions of miles, sure, but pretty close in space terms. It's in the constellation Southern Fish, the one that looks like a single fish floating in the southern night sky. It's a small and relatively dim constellation, but Fomalhaut is what makes it so special. In Arabic, this means mouth of the fish, and you might guess where that name comes from. It's the brightest star in the constellation. If you're in the southern hemisphere, you can easily spot Fomalhaut with the naked eye. For people in the northern hemisphere, it's visible in the fall, low on the southern horizon. But this constellation has a beautiful story. The myth says that this fish is the one that saved the deity Durcedo, who had fallen into a lake. So it became the symbol of rescue and protection. The fish in Pisces is said to be the offspring of the southern fish, forming a kind of family. At the same time, Fomalhaut is sometimes called the lonely star because it's one of the brightest stars in its part of the sky, but it doesn't have many bright neighbors. Hey, I can relate to that. Nah, just kidding. Fomalhaut is also a young star. It's only about 440 million years old. Now that sounds like a lot, but our Sun, in comparison, is 4.6 billion years old. And finally, it's surrounded by a giant ring of dust and gas. This is called a debris disk. It's like a dust cloud that serves as the birthplace of planets. It's like the Kuiper Belt in our own solar system, where Pluto lives, but on a much grander scale. But then, astronomers noticed something odd about this disk. It wasn't evenly shaped. This means that there's something that influences gravity nearby. A planet, perhaps? And when they took pictures of the disk, they found a faint glowing dot inside it. That was our mysterious gravity center, Fomalhaut b, or how they named it later, Dagon. They immediately thought it was a planet. In 2008, it was a huge deal because scientists captured an actual image of it using the Hubble Space Telescope. Now that's a super rare thing, especially for objects outside our solar system, not to mention such tiny things as planets. And the photos were fascinating. At first, everyone was excited about the new world. Scientists thought that Dagon was a massive planet, something maybe like Jupiter, a gas giant. They even guessed that it had an oval-shaped orbit, which means that it would take about 1,700 years to go around its star just once. It's one of the craziest orbits we've ever seen. But as they kept studying Dagon, they noticed that things don't add up. For starters, they couldn't find it in infrared light. Now, planets that big usually give off heat, and telescopes like Spitzer which looked for heat signals, found nothing. Weird, right? Also, the planet was moving too strangely. Its orbit didn't match what you'd expect if it were shaping the dust ring. So scientists started thinking, maybe it's not a planet at all. And as the doubts creeped in, the hype calmed down. In 2020, they noticed another strange thing about Dagon. It was getting dimmer and spreading out. And well, planets don't usually do that, but clouds of dust do. This led to a new idea. What if Dagon isn't a planet, but the result of a massive collision? Imagine two big chunks of ice or rock smashing into each other at incredible speeds. That's what they think happened here, a giant space crash that led to lots of debris. That's how it got officially removed from the list of exoplanets. But then, in 2023, the new James Webb Space Telescope, which is even more powerful than Hubble, decided to take a closer look at Dagon. And when scientists looked at the data, they jumped back into the previous debates. Wait, it might be the planet after all. All this scientific back and forth led to Dagon getting dubbed the zombie planet. But after a while, astronomers finally found the middle ground. Dagon really turned out to be a dust cloud that's slowly disappearing, but there could still be hidden planets in the system. There's another ring of dust closer to the star that might be shaped by an unseen planet. There are many mysterious weird planets out there. Trace 2b orbits a star 750 light-years away from Earth, much farther out than our Dagon. It's in a region of the sky that's been heavily studied by planet hunters. It was first discovered in 2006 by the Transatlantic Exoplanet Survey, an observatory with a bunch of cool telescopes that are used to find planets. They use a witty method for it. They observe the stars, and when they see unexpected dips in brightness, that means that something must be passing in front of the star, making it a wee bit darker. This is called the transit method of the planet discovery. When Trace 2b was spotted that way, scientists took a closer look and confirmed it. It had a certain gravity pull that caused its star to wobble. But that also means that the planet should be gigantic, probably a gas giant like Jupiter or Saturn. But, unlike Jupiter, Trace 2b is much closer to its star. This makes it a special type of a planet called hot Jupiter. That's what we call gas giants that orbit so close to their stars that their atmospheres are scorched to extreme temperatures. Imagine if Jupiter was not only horrifyingly massive, but also almost burning. This planet is tidally locked to its star. This means that it always faces the sun with one side, just like we can only see one side of our moon. Its day side is blisteringly hot, but even the cooler night side has temperatures around 2,900 degrees Fahrenheit. But there was something very eerie about this new world. What really made it stand out was its albedo, a measure of how much light the planet reflects. Most planets, like Jupiter or even Earth, reflect a good amount of light thanks to clouds, ice, and other stuff. This is what allows us to see those planets after all. But Trace 2b is almost completely black. For some reason, it reflects less than 1% of the light that hits it. It's darker than coal or fresh asphalt. So, why is that? After some thought, astronomers think it might be because of its atmosphere. Jupiter has bright reflective clouds of a gas called ammonia, but Trace 2b probably doesn't have those. Since it's so close to its star, they'd burn up and get stripped away. So, its atmosphere might be made up of chemicals like sodium, potassium, or titanium oxide. All of this stuff absorbs a lot of light, and if you look directly at that planet, you'd see it almost as a black hole. What's even more horrifying is that if you were floating in it, since it doesn't have a solid surface, these elements could make the sky above look like an endless void, even if it's daytime. Though you'd probably still see its star, even it would be completely surrounded by blackness, like light at the end of a tunnel. In that case, shouldn't it be completely invisible? Well, it kind of is, but it also emits a faint red glow, likely due to its scorching high temperature. And even though scientists have studied Trace 2b for years, some questions remain unanswered. Why is it the darkest planet we've ever found? Is it possible that there are some unknown chemicals in its atmosphere? What hides beneath the darkness? These Jupiter-like planets are often crazy, like WASP 76b, for example. This is another gas giant located about 640 light-years away, this time in the constellation Pisces. Just like Trace 2b, this exoplanet is tidally locked. One side has a temperature of over 4,000 degrees Fahrenheit, while the other side remains in constant darkness. But what's crazy about it is that the extreme heat on the day side vaporizes metals like iron. The planet has insanely strong winds, and they blow this molten iron to the colder side. And you guessed it, the iron gets solid under colder temperatures, and we end up with a horrifying iron rain. All this stuff sounds like science fiction, but it's real, waiting to be explored.
Look at this fascinating planet. It looks as if it's burning. It must be hotter on its surface than in the middle of Death Valley. The ground is parched, cut by giant cracks. There's not a drop of water in this boiling world. Now, it's the same planet, but it looks like a totally different place. Everything is frozen. The temperatures are so low, there isn't even a tiniest chance that life could survive on this planet. This bizarre world is called HD 20794d, and it's located 19.7 light-years away from Earth in the constellation Eridanus. This planet is a super-Earth. This term means that it is larger than Earth but smaller than such ice giants as Neptune. What makes this planet especially interesting is its unusual orbit, which moves it in and out of its star's habitable zone, the region where temperatures might allow liquid water to exist. Now, we haven't seen this unusual planet directly. Astronomers detected it by measuring tiny wobbles in its star using two powerful instruments, espresso and HARPS, located at telescopes in Chile. These instruments measure radial velocity, which is the small movement a star makes as a planet's gravity tugs on it. The larger the wobble, the more massive the planet. Later, astronomers analyzed the data and figured out that the planet in question has a mass around 6 times greater than Earth's. It orbits a star, which is slightly smaller and dimmer than our Sun. What makes this star unique is that it is bright enough to be seen with the unaided eye, unlike many other stars that host exoplanets. You won't be able to see them without a telescope. The star system has been observed for over 20 years. Astronomers have long suspected it had multiple planets. In 2011, scientists discovered 2 other super-Earths orbiting the star every 18.3 and 89.6 days, respectively. For some time, researchers thought they had found a third planet with an orbital period of 40 days. Later, they realized they had made a mistake. But recently, after reanalyzing years of data, astronomers have confirmed that the third planet does exist, and it's our extreme HD 20794d. A researcher from the University of Oxford played a key role in identifying the planet. He used a special computer algorithm called Yarara to separate the planet's weak signal from the background noise. It helped him confirm that the planet truly existed and was pretty unique. Unlike the planets in our solar system, which have mostly circular orbits, the newly discovered one follows a highly elliptical, stretched-out orbit. It takes 647 days to complete one trip around its star. That's just 40 days shorter than Mars's orbit around the Sun. At its furthest point, the planet is twice the Earth-Sun distance, which makes it an icy world far outside the habitable zone. At its closest point, it moves inward to 0.75 AU, where it enters the habitable zone, where liquid water might exist. This extreme movement creates truly bizarre seasons. For some part of its orbit, HD 20794d is frozen, like an icy wasteland. As it approaches its star, temperatures rise and ice likely melts, forming temporary oceans. The planet then experiences a short, scorching summer. It is so hot that the water on its surface might evaporate into the atmosphere. Shortly after, the planet moves away again. It triggers a gloomy fall with rains, followed by a deep freeze in winter. In other words, the planet switches between extreme cold and intense heat, which makes it a very unpredictable place for life. If any life forms exist there, they certainly need to adapt to dramatic changes in temperature and environment. Why does the planet follow such a mind-boggling orbit? It might be a leftover effect from events billions of years ago, when the planetary system was still forming. At some point, another large planet may have disturbed the orbit of our extraordinary friend. Another possible explanation is that a giant planet once existed in the system, and its gravity pushed HD 20794d into an elongated path. Later, this giant planet may have been ejected from the system, leaving the smaller planet in its current orbit. This theory makes sense because the two other planets in the system, B and C, have more normal circular orbits. The discovery of this planet is so exciting because it challenges what we know about habitable planets. Most planets in the habitable zone stay there permanently, but HD 20794d only passes through it. Scientists want to know if such a planet could still support life, even briefly. So future telescopes will study the atmosphere of this planet, looking for signs of water, gases, or even life. Another super-Earth that might have the right conditions for life orbits a star 137 light-years away. In space terms, this is considered relatively close. A light-year is around 6 trillion miles. The planet is called TOI 715b, and it's about 1.5 times the size of Earth. Unlike HD 20794d, it's permanently located in the habitable zone. Look, that's what astronomers think the planet might look like. TOI 715b orbits its star very quickly, completing a full orbit in just 19 days. But even though it's close to its star, it may not be extremely hot, all because its star is a red dwarf. That's a type of star that is smaller and cooler than our Sun. This means TOI 715b could have a milder temperature compared to other exoplanets that orbit closer to hotter stars. NASA discovered the planet using the Transiting Exoplanet Survey satellite. This space telescope finds planets by watching for small dips in a star's brightness, which happen when a planet passes in front of it. Since red dwarfs are smaller and dimmer than the Sun, planets passing in front of them are easier to detect. Astronomers are planning to study the planet further using the James Webb Space Telescope. This powerful telescope, located 1 million miles away from Earth, can analyze the atmospheres of distant planets. If TOI 715b has an atmosphere, JWST could help scientists determine what gases are present in it and whether such conditions could support liquid water or even life. One more promising world for our search for extraterrestrial life is an extremely dense super-Earth in the K2360 system. An international team of researchers from Japan and Europe has discovered this remarkable multi-planet system orbiting a Sun-like star located 750 light-years away. This system has 2 planets, including one of the densest rocky planets ever found. The K2360b is a rocky super-Earth, about 1.6 times the size of Earth, but with a mass 7.7 times greater. This makes it as dense as lead. The planet orbits its star incredibly fast, completing one full orbit in just 21 hours. It's the densest known ultra-short period planet with well-measured properties. As for its sibling, this is a much larger outer planet with at least 15 Earth masses. It takes 9.8 days to orbit its star. Sadly, since it does not pass in front of its star from our viewpoint, scientists cannot determine its exact size. The unusually dense planet might be the core of a much larger planet. Over time, intense radiation from its parent star may have blown away its outer layers, leaving behind only its dense, rocky core. So, in fact, this planet could show us what might happen to some planets that are too close to their stars. Astronomers think that the planet may have moved inward over time due to interactions with its larger companion planet. One possibility is high eccentricity migration, where a planet's orbit becomes highly stretched out due to gravitational interactions before gradually becoming more circular near the star. Another theory is that the planet's spin and axial tilt can cause its orbit to become more circular. Such planets are rare, and finding one with a massive outer companion can help scientists refine their theories about how planets form and evolve in extreme environments. With its help, we might also understand how rocky planets evolve and what happens to planets that get too close to their stars.
You're standing next to a huge, floor-to-ceiling window of the spaceship/wandering city you've been calling your home for a dozen years, along with a few hundred other people. You're watching a fascinating object nearing your spaceship, wondering if it'll bring an end to this journey and your life. It looks like an asteroid, but acts like a comet, moving as if something is pushing it. Can it be the engine created by another space civilization? Are you doomed, or are you about to have contact with a different kind of intelligence? Now, let's leave this post-apocalyptic fantasy and take a closer look at these space invaders called dark comets. The most intriguing question is obviously, what makes them move? Most likely it's some gas or material escaping from the surface of these space objects. Interestingly, until recently, no one has even been sure they existed. The first dark comet was discovered just a few years ago, and since then, researchers have identified 14 of them, including 7 new ones found just recently. The story of dark comets began in 2016, when scientists noticed something strange about an asteroid called 2003 RM. Its orbit wasn't quite what they expected. It had shifted slightly, and no one could explain that shift by typical asteroid behavior, when they received tiny pushes caused by sunlight heating an asteroid unevenly. Instead, the movement suggested that 2003 RM might have been releasing material, something comets often do. But there was a catch. The thing didn't look like a comet. There was no tail, no visible gas cloud. It was just a tiny dot of light, like a regular asteroid. At first, scientists thought 2003 RM was just a one-off mystery. But in 2017, a telescope spotted another strange object, this one from outside our solar system. It was Oumuamua. It too looked like an asteroid, but had a path that changed as if gas were escaping from it. The similarities between Oumuamua and 2003 RM made researchers think there might be more of such odd objects out there. By 2023, 7 more had been discovered in our solar system. These discoveries were enough to give this new type of object the name of dark comets. Now, scientists have enough data to start noticing patterns and learning more about their characteristics. And so, they have identified 2 main groups of dark comets. The first group, called outer dark comets, is larger, with sizes ranging from hundreds of feet to even more. They follow long elliptical orbits, similar to traditional comets that come from regions near Jupiter. The second group, inner dark comets, is smaller, usually tens of feet across. These comets move in almost circular orbits and stay closer to the Sun, near planets like Earth, Venus, and Mars. The main question these days is, where do dark comets come from? Can they be the remnants of larger bodies that broke apart? These space bodies could help us understand the history of the solar system. What if they had delivered the ingredients for life to early Earth? Once we study dark comets better, we might figure out if they contain materials like ice or organic compounds. And indeed, some researchers are sure that dark comets may contain or once have contained ice and played a big role in bringing water to Earth. According to a couple of studies, some asteroids in the asteroid belt, a region between Mars and Jupiter filled with rocky debris, might have ice beneath their surfaces, and this ice from the asteroid belt could have traveled into near-Earth space. In other words, it could be a pathway for water to reach our planet. So far, no one is saying that dark comets definitely brought water to Earth. but they might be another mechanism for moving ice from one part of the solar system to another. The study also hints at a connection between dark comets and a group known as Jupiter family comets. These are comets whose orbits are strongly influenced by the gravity of Jupiter, often pulling them inward toward the Sun. This connection makes it even more difficult to understand where dark comets come from and how they behave. Now, let's take a closer look at the differences between asteroids and comets. Traditional asteroids are rocky bodies that orbit relatively close to the Sun, typically within the ice line. This region is so close to the Sun that any ice on an asteroid's surface would turn directly from a solid into a gas, leaving behind only rock. Comets, in turn, are icy bodies that form farther from the Sun. When they approach the inner solar system, their ice starts turning from a solid to a gas tube, creating a visible cloud called a coma or a tail while releasing dust and gas. Dark comets blur these definitions. They appear as rocky asteroid objects without a coma or tail, but they have behavior typical of comets, and that's small non-gravitational accelerations. These accelerations occur when ice turns into gas, giving the object a slight push. After analyzing 7 known dark comets, astronomers estimated that between 0.5% and 60% of all near-Earth objects might belong to this mysterious category. And since dark comets likely come from the asteroid belt, ice is likely to exist even in the regions of the belt previously thought to be too warm. Now, near-Earth objects like dark comets don't stay in the same orbit forever. The near-Earth environment is unstable, and objects typically remain there for about 10 million years. Since the solar system is over 4.5 billion years old, this means that new near-Earth objects must constantly replace those that are lost. Now, astronomers have used computer models to simulate the movement of objects under the influence of non-gravitational accelerations. They've traced the paths of these objects over a span of 100,000 years and discovered that many ended up in the same regions where we find dark comets today. Now, do you remember that space rock 2003 RM, which was the first to be called a dark comet? Well, it provided a particularly interesting clue. Its elliptical orbit brings it close to Earth, then out near Jupiter, before returning to Earth again. This trajectory matches what scientists would expect from a Jupiter family comet, an object that was likely knocked inward from its original orbit. Most of the other dark comets studied, however, seem to have come from the inner regions of the asteroid belt, closer to Mars. Dark comets are often small and spin rapidly. Astronomers often describe them as dirty ice cubes, all because these objects are a mix of rock and ice, and when they cross the ice line, their ice begins to turn into gas. This process not only causes those small non-gravitational accelerations, but also increases their spin rate. And the faster these objects spin, the easier they can break apart into smaller fragments. The pieces that break off also have ice, and as they spin faster and faster, they break into even smaller pieces. This process continues until you're left with very small, fast-spinning objects. This cycle of fragmentation helps explain why dark comets are often so tiny. But it could also mean there are more of them than we currently know about. The dark comet research provides new insights into the distribution of ice in the solar system and its potential pathways into the near-Earth environment. It also raises intriguing questions. For example, how much ice remains hidden in the asteroid belt? Or could dark comets have played a role in delivering water or organic materials to Earth? One of the most important points is that dark comets may represent a significant part of near-Earth objects. If it turns out to be true, it could mean that our understanding of the population of near-Earth objects and their potential risks for our planet is far from complete. The processes shaping dark comets, from sublimation to fragmentation, could be a major factor in the evolution of icy bodies throughout the solar system. Luckily, these days, scientists have an opportunity to combine advanced modeling with observations, which can eventually shed light on that very elusive class of objects that could have clues to the history of water and life on Earth.
So the idea of panspermia is that life can travel through space naturally, like seeds being spread around the universe. It's been debated for ages, but we didn't have any proof until recently. Now, with new discoveries and research, we're taking it seriously. People used to think it was impossible for living things to survive being launched off one planet, traveling through space, and land on another planet. But turns out microorganisms can handle it. Scientists got interested in this again in the 70s when they found rocks from Mars here on Earth that proved it's possible for rocks to travel between planets in our solar system. They figured out some ways that materials can be sent into space and survive the trip. So yeah, panspermia might be a real thing after all. Basically, scientists were wondering if living things could have hitched a ride between planets in our solar system. But for that to happen, microorganisms would need to survive being launched off of one planet, flying through space, and then landing on another planet. So, scientists have done a bunch of experiments trying to simulate all those crazy conditions. They found that spores can survive each stress individually, and even combined stresses can be simulated in the lab. For instance, microbes could totally survive the trip from Mars to Earth or any other habitable planet in our solar system. And get this, it's not just Mars and Earth that could be swapping germs. There are all these cool moons around Jupiter and Saturn that might be habitable too, like Io, Europa, Ganymede, Callisto, Titan, and Enceladus. Plus, microbes can survive in space for years with just a little UV protection. Like they could be space superheroes with a dash of sunscreen. And if they're shielded by 6.5 feet of meteorite, they could live for 25 million years up there. That's longer than most marriages last. But wait, it gets crazier. Scientists found microbes on Earth that were brought back to life after 250 million years. That's like finding a fossil and then it jumps up and says, "Surprise!" All these discoveries have changed the game when it comes to finding life on other planets. We used to think life could only exist on cushy Earth-like planets. But now we know that extreme environments are fair game. And with our improved knowledge of these environments, we've been able to develop astrobiology, which is all about studying the origin, evolution, and distribution of life in the universe. Mars is one of the most promising places to look for life. We've found evidence that it used to have an environment similar to Earth, which means life could have flourished there. And get this, scientists found trace amounts of methane in the Martian atmosphere that could be produced by living organisms. Plus, they recently discovered subsurface liquid water lakes on Mars. So, maybe there are some Martian microbes chilling down there. Europa is another exciting prospect. It has a subsurface ocean that could support life similar to Earth's deep ocean hydrothermal vents or the Antarctic lake Vostok. And Enceladus has hydrothermal vents on its subsea floor and high-speed jets of water vapor and organic-rich particles gushing out from its southern region. So who knows what kind of alien creatures are lurking out there? Bottom line, space is wild and full of surprises. Who knows what kind of crazy stuff we'll find next? Yeah, that long explanation was all about panspermia. But that's definitely not the only theory about the origins of life in space. There's just panspermia theory, but there's also directed panspermia. This theory is a bit crazy though. It suggests that life on Earth was deliberately seeded by an advanced extraterrestrial civilization. This idea is based on the assumption that life is rare in the universe and that it's unlikely to have originated on its own on Earth. Directed panspermia is basically the idea that dudes from other planets intentionally sent life to Earth. I'm not kidding you. Some people think that extraterrestrial beings might have purposely sent microorganisms or even whole organisms to our planet to kickstart life here. The idea is that those dudes might have wanted to spread life throughout the universe, and Earth was just one of their stops. It's kind of like intergalactic gardening. They planted the seeds of life and let it grow. Now, this theory might sound a little out there, but some scientists actually take it seriously They argue that it's possible that life on Earth is too complex to have just randomly formed on its own, and that an outside force had to have played a role. I personally prefer classic panspermia theory over this one. There's another theory called chemical evolution, and it suggests that life on Earth originated from simple organic molecules that formed spontaneously in the early Earth's atmosphere or in space. These molecules then combined and evolved into more complex structures, eventually leading to the formation of living organisms. The conditions on early Earth were different from what we see today. The atmosphere was mostly composed of gases like methane, ammonia, and carbon dioxide, and there was no oxygen. These conditions were conducive to the formation of organic molecules. One of the most famous experiments that supported the chemical evolution theory was the Miller-Urey experiment in 1952. In this experiment, Stanley Miller and Harold Urey simulated the early Earth's atmosphere in a laboratory and produced amino acids, which are the building blocks of proteins. This experiment demonstrated that organic molecules could be formed from simple inorganic compounds under conditions similar to those found on early Earth. Over time, these simple organic molecules combined and evolved into more complex structures, eventually leading to the formation of living organisms. This process is believed to have taken millions of years and involved many intermediate steps. While chemical evolution is still a theory, and there are still many questions to be answered about the origins of life, it provides a plausible explanation for how life could have arisen from non-living matter. Hey, ready for the next theory? Meet hydrothermal vent theory. This one suggests that life on Earth originated near hydrothermal vents on the ocean floor. These vents provide a unique environment where chemicals and minerals mix with hot water, creating conditions that could have supported the formation of organic molecules and the evolution of life. This theory is another idea about how life could have started on Earth. Basically, it suggests that deep under the ocean, there are these hot vents where water, heated by the Earth's core, comes out. These vents are full of minerals and chemicals that could have provided the perfect conditions for life to begin. Scientists think that the first living organisms could have started around these vents, using chemicals and minerals to create energy. Over time, these organisms evolved and spread out into other parts of the ocean. The hydrothermal vent theory is still being studied and debated, but it's an exciting idea that could help us understand how life began on our planet. The last, but not the least, RNA world hypothesis. This theory suggests that RNA, aka ribonucleic acid, was the first self-replicating molecule that led to the evolution of life on Earth. RNA is capable of both storing genetic information and catalyzing chemical reactions, making it a possible precursor to DNA and proteins. Basically, the name of this hypothesis is a fancy way of saying that life on Earth might have started with a molecule called RNA. RNA is like a cousin to DNA, which is what makes up our genes. Scientists think that RNA might have been the first molecule that could make copies of itself, which is a key part of how life works. The idea is that in the early days of Earth, there were all these chemicals and stuff floating around, and somehow these chemicals combined to make RNA. Then, because RNA could make copies of itself, it started to spread and evolve into more complex forms of life. It's still just a theory, but it's a pretty cool one. And who knows, maybe we'll find out one day that it's how we all got here. Have you heard about Planet 9? No, not Pluto. We're talking about something lurking on the outskirts of the solar system. A mysterious planet that exists in our solar system that we haven't yet discovered. We've been looking for it for years, but finally, it seems like scientists found a key to solve this mystery. Planet 9 is a hypothetical planet. Astronomers have been on the hunt for it for quite some time now. But it's so elusive that they've only been able to piece together a few details about its potential characteristics. One thing we do know is that Planet 9 has to be a massive world, possibly up to 10 times the mass of Earth. That's one big planet. It's also thought to be a distant wanderer, hanging out somewhere between Neptune and Pluto. Some scientists think that Planet 9 might actually be a mini Neptune, with a thick, gaseous atmosphere and a rocky core. Others speculate that it could be an icy world with a solid, frozen surface and a thick layer of hydrogen and helium gas. Of course, since we haven't actually found Planet 9 yet, we can't say for sure what it's like. We're not even sure that it even exists. Some say it's just a myth, like the Tooth Fairy or the Easter Bunny, but others are convinced that it's out there somewhere. And at the end of the day, we're not entirely sure if Planet 9 is even a planet. It might be a special kind of black hole or made entirely of dark matter. The search for Planet 9 began in the early 21st century when a group of astronomers realized that something wasn't quite right with the outer reaches of our solar system. They noticed that some distant objects, known as trans-Neptunian objects, were behaving in unexpected ways. Trans-Neptunian objects, or TNOs, are like the cosmic version of those items in the back of your fridge that you forgot about for years. They're small, icy bodies that hang out in the Kuiper Belt, beyond Neptune. So, scientists noticed that these guys started behaving weirdly. At first, they thought it might be a fluke. But as they dug deeper, they began to suspect that there was a ninth planet lurking out there. Why haven't we discovered it yet, you ask? Well, it may be because of Planet 9's weird orbit. All the other 8 planets orbit the Sun in roughly the same plane, which is like a flat disk. However, our hypothetical friend's orbit is different. It might be tilted and move in a different direction compared to the other planets. Its orbit might also be stretched out like an oval, rather than being nearly circular like usual. Because of this, Planet 9 might spend most of its time far from the Sun, like a true introvert. It only comes relatively close to the inner solar system every few thousand years. This would make it super faint and hard to spot, so the only way we may discover it is by studying the gravitational effects it has on our solar system. And this isn't the first time astronomers have gone looking for a new planet. Back in the 19th century, there was a similar hunt for a hypothetical Planet X. But this time, they were armed with much better technology and a much better sense of humor. They began calling their elusive quarry Planet 9, which was much catchier than Planet X. They even came up with a hashtag for the search, Pluto Lives. It was a reference to the fact that Pluto had been kicked from the planet gang and some astronomers were eager to find a new planet to take its place. But the search for Planet 9 has been no easy task. It's like trying to find a lost sock in the laundry basket the size of a football stadium. It's so far away and so faint that even the most powerful telescopes can't see it. Instead, astronomers have had to rely on indirect evidence, like the strange orbits of TNOs, to try to figure out where it might be. Some scientists have even supposed that it might be a wandering rogue planet, which would explain why it's so hard to find. But they haven't given up hope. Till this day, they're scouring the skies using all sorts of high-tech telescopes and fancy algorithms to try and spot this elusive planet. And fear not, dear curious human, because it looks like after so many years of research, we may have finally found the key to solve this mystery. Astronomer Man Ho Chan from Hong Kong has a theory. He believes that Planet 9 could have a bevy of moons. That's right, not only is it a giant planet hiding out in the depths of space, but it's also a bit of a hoarder. Moons are all the rage in the outer solar system. In fact, almost every planet here has at least one moon, except for Mercury and Venus. Earth has just one, which is kind of sad if you think about it. Even non-planetary bodies like Pluto have at least a couple of moons. A bit unfair, isn't it? Anyway, taking this into account, let's go moon picking with Planet 9. The region between the rock-filled Kuiper Belt and the rock-filled Oort cloud, where this planet is predicted to be, should be ripe for the picking. Chan made some calculations and determined that it would be stranger if the elusive planet didn't have any satellites. According to his calculations, an object the mass of Planet 9 should capture at least 20 TNOs as large as almost 90 miles across. It's like our mysterious planet is playing cosmic Pokemon with these guys. So, what if Planet 9 has moons? Would that make any difference? Kinda yes. They could give us some indirect clues to finally locate this mysterious planet. Now, you might be thinking, how in the cosmos can we possibly spot these teeny tiny moons? It's not like they're going to wave a giant flag or blast some Beyoncé tunes to get our attention. Well, apparently the key lies in something called tidal heating. Tidal heating might sound like a new workout trend, but it's a real scientific phenomenon. It happens when two celestial bodies are close together. You see, tides aren't just about the rise and fall of the ocean, they're also the result of gravity pulling unevenly on a planet or moon. When a planet and a moon are close enough to each other, their gravity pulls on each other, creating a bit of a football shape. And as these celestial bodies move around each other, they shift shape and generate friction inside, which produces heat. Wow, who knew that Planet 9 could have a workout routine? Perhaps we should start calling it Gym Planet instead. Anyway, if Planet 9 has any moons, the gravitational pull from these moons would cause it to change shape constantly, generating heat in the process. And we might be able to detect this mysterious planet through the heat produced by those moons, even though it gives off no other signals. Now, before you get too excited, finding them won't be a walk in the park. They're incredibly small and would be very far away from us. But hey, nothing worth discovering ever came easy, right? Scientists are optimistic that with the right technology, they can spot this telltale sign. It will be easier for us to spot them with fancy instruments like modern telescopes. Talk about cool friends to have, right? Sure, the process of finding it may be difficult and time-consuming, but the potential payoff is huge. Finding this planet could explain a lot of the strange behavior observed in TNOs, the Kuiper Belt, and beyond. As we've already mentioned, they've been acting super weird lately, tilting and aligning in suspicious ways. If this planet doesn't actually exist, we have yet to explain what is the reason for this strange behavior. In any case, the search for Planet 9 is one of the most exciting and intriguing quests in modern astronomy. It's like a cosmic scavenger hunt, and everyone's invited to join in on the fun. So, grab your telescopes and let's go planet hunting. Who knows, maybe we'll find it sooner than we think.
Guess what? The universe can get actual scars, just like when you fall off a bike. Well, here's why. Before the Big Bang, the universe was extremely hot, dense, and full of energy, and it seemed like everything was going well, until that all changed about 13.8 billion years ago. Then the universe exploded. After the blast, it expanded incredibly quickly. Our human brain can't even perceive how fast that expansion was. Sometime later, the universe started cooling down. As it did, giant, terrifying scars cutting through space-time appeared all over the place. And if we study these scars well, we can even get insight into time travel. These days, we call these scars cosmic strings. They're like stretch marks that appear when the skin expands too quickly. Or we could also compare them to cracks that form in the ice when it freezes. These strings are likely very thin, about the size of a proton, a positively charged subatomic particle. Yes, subatomic means smaller than an atom. The strings are also extremely dense and can stretch for light years. Now, imagine these cosmic scars floating through space, not interacting much with their surroundings. When two cosmic strings pass each other, they could warp space-time in such a way that it creates a time machine. If you were to travel along a certain path around these strings, you would end up returning to your starting point at an earlier time, which is traveling back in time. Now, let's admit it, this idea sounds like something from science fiction, but it's supported by cosmic string theory, and the math behind it seems to work. Unfortunately, no one has observed cosmic strings yet, so for now, it's still a theory. In 1991, one physicist proposed an idea for how cosmic strings could enable time travel. If two infinite cosmic strings passed each other in parallel, they would warp space-time, creating a time loop. This loop would allow someone to travel back in time. Even better, this idea doesn't contradict Einstein's theory of general relativity, which suggests that large objects can bend space and time. These bends in space-time could allow a shortcut through time. His now well-known concept of closed time loops also helps explain how wormholes might work. So, a wormhole is basically a theoretical tunnel connecting one place in space to another. Some people believe that by using such tunnels, we could create shortcuts for incredibly long journeys through the universe, which would allow us to visit other star systems and galaxies. So, let's say you manage to create a wormhole and even accelerate one of its ends to near the speed of light, and then you send it back to where it came from. Well, at that moment, those two ends are not synced anymore. One is in the past, while the other is in the future. And if you somehow manage to walk between them, you'd be time traveling. You could do something similar by placing one end of the wormhole near a powerful gravitational field, like a black hole, and keeping the other side near a weaker gravitational force. This way, according to the theory of relativity, time would pass more slowly nearer to the strong gravity side, and it would allow a particle or another chunk of mass to remain in the past relative to the other side of the wormhole. At the same time, if you decided to create a wormhole, you'd have to keep in mind that they are super dangerous. They might collapse all of a sudden. They're likely to be highly radioactive, or you could come into contact with toxic exotic matter inside. But let's get back to the math behind the cosmic string time machine idea. Admittedly, it is solid, but it doesn't mean such a time machine is possible yet. To use this way of time travel, we'd need to reach near light speed, and it might be impossible. According to Einstein's relativity, the faster an object travels, the more energy it needs to continue speeding up. In other words, we don't yet have the technology or energy sources to accelerate a spacecraft to these speeds. The idea of two infinite cosmic strings is also questionable because we can't create something that's infinitely long. So, while this time travel model is mathematically sound, the infinite nature of the strings would make this exact model impractical. At the same time, some scientists still believe that cosmic strings are a better possibility than most other models, like wormholes. In any case, before we can start considering time travel, we need to discover cosmic strings. Luckily, there's a group of astronomers working to detect low-frequency gravitational waves by measuring signals from a type of star called a pulsar. Now, pulsars send out regular pulses of radio waves, and by measuring small changes in the timing of these pulses, scientists can detect subtle shifts in space-time. Those changes are caused by gravitational waves, which are ripples in space-time. Now, so far, we've only detected gravitational waves coming from black holes. But in 2020, there was one strange signal that didn't look like it came from black holes. It could be coming from cosmic strings. And here, we need to mention string theory. According to it, the universe is made up of more than just the four dimensions of space-time. There are additional dimensions that are hidden from us. Plus, the basic building blocks of the universe aren't particles, but tiny vibrating strings. These strings can vibrate at different frequencies to create different fundamental particles. These strings, from string theory, could have stretched out during the early universe and become the very cosmic strings we've discussed. In the coming years, we might get more information about them from a space-based gravitational wave telescope called LISA. It's supposed to launch in 2035. But if the signals picked up in 2020 really came from cosmic strings, it could mean a huge breakthrough in physics. In this case, string theory would become the right framework for understanding the universe. It would completely change the way we think about the building blocks of our reality. On the other hand, even if the signals don't turn out to be from cosmic strings, this discovery would still be important. It would give scientists more information on what cosmic string signals might look like in the future. And while we're not yet at the point of time travel, the discovery of cosmic strings could take us one step closer to understanding the mysteries of the universe and maybe even the possibility of traveling through time. Now, time travel is a popular theme in science fiction, but in fact, moving forward in time happens naturally. Right now, you are traveling into the future at a steady rate of 1 second per second. However, scientists have discovered that this rate can change depending on speed and gravity. Einstein's special theory of relativity explains that time slows down as an object moves faster. The closer you get to the speed of light, the more slowly time passes for you, compared to someone who isn't moving at all. The general theory of relativity adds another factor: gravity. The stronger the gravitational pull, the more slowly time moves. Near massive objects, such as the surface of a neutron star, black hole, or even Earth, time runs more slowly than it does far away from these space objects. If someone were to stay near the edge of a black hole, where gravity is incredibly strong, only a few hours might pass for them, while thousands of years would go by for people on Earth. If they returned, they would have effectively traveled into the future. This is a real and scientifically proven effect. A real-life example of time travel, though on a tiny scale, can be witnessed in space missions. For example, this cosmonaut spent a total of 748 days aboard the space station Mir during 3 separate missions. Because Mir was moving at high speeds relative to Earth, it experienced time dilation. As a result, he aged 0.02 of a second less than had he stayed on the ground. Now, this difference may seem tiny, but it shows that time moves differently depending on speed and location. But while traveling to the future is scientifically possible, traveling to the past is much more complicated and controversial, and leads to logical paradoxes. Imagine you throw a billiard ball into a time machine. It travels to the past and collides with its earlier self. This prevents the ball from ever entering the time machine in the first place. A contradiction.
The moon's volcanoes are not dormant, and they can erupt any minute. For years, we lived knowing nothing about it, but now it's officially proven thanks to China's Chang'e 5 mission's shocking discovery. The lunar soil samples it brought back to Earth contained something absolutely unexpected, hinting that volcanic eruptions may have occurred on the moon as recently as 123 million years ago. Geologically, that's practically yesterday. But the big question is, are we safe down here on Earth? We've long known that the moon was once volcanically active due to the dark regions, lunar maria, on its surface. These maria, the dark plains that give the moon its characteristic markings, are ancient lava flows that date back to around 3 to 3.8 billion years ago. Until recently, scientists thought that those ancient flows marked the end of the moon's volcanic activity. But the Chang'e 5 mission brought back lunar soil that included several microscopic glass beads, and 3 of them in particular revealed an extraordinary story. They formed around 123 million years ago from volcanic eruptions. An uncertainty range is a mere 15 million years. The discovery of those tiny beads is super important because of their composition and rarity. Measuring between 20 to 400 microns, which is smaller than a grain of sand, these beads are volcanic in origin. And this fact sets them apart from most other lunar glass beads, which typically form due to meteor impacts. Impact events on the moon create glass by melting surface rock with incredible heat and pressure. The result is tiny glass beads scattered all over the landscape. Yet, the volcanic beads identified in Chang'e 5's sample were formed by magma erupting from beneath the moon's crust. and cooling it into glass as it reached the surface. By using uranium-lead dating, which measures the decay of uranium into lead within the beads, scientists managed to pinpoint their age with striking accuracy. The results suggest that the last known volcanic activity on the Moon happened within the past 200 million years, making it a recent event in the Moon's long history. This discovery also aligns with prior observations of unusual surface features known as irregular mare patches. Those are smooth mounds surrounded by rocky terrain. They were first spotted by NASA's Lunar Reconnaissance Orbiter in 2014. These patches appear much younger than other lunar features, potentially formed by volcanic eruptions less than 100 million years ago. Before Chang 5's glass beads, these irregular mare patches were among the best evidence of recent volcanic activity on the Moon. Yet, without confirmation, their origins remain uncertain. And now, the glass beads confirm volcanic action. The findings raise new questions about the Moon's inner workings. In particular, how could it retain enough heat to sustain volcanic eruptions? We thought that the Moon had cooled significantly after its formation 4.5 billion years ago, which made it volcanically inactive. And without tectonic activity or an atmosphere, the Moon should have shed its internal heat long ago. Yet the beads suggest the possibility of some localized heat sources within the Moon's mantle. Scientists think that heat-producing elements such as potassium and thorium might be creating small, warm pockets which generate enough heat to melt rock and trigger isolated volcanic eruptions. But wait, beyond rewriting the Moon's history, this discovery adds an intriguing twist to ongoing studies of transient lunar phenomena. These sightings, often reported as ghostly glows or hazes by amateur astronomers, remain unconfirmed by scientific probes. Some experts just dismiss them as illusions caused by Earth's atmosphere. But if the Moon has small pockets of volcanic or outgassing activity, TLP might have a real basis. Gases emitted from beneath the surface could explain such mysterious glows and possibly be a hint of residual volcanic action on the Moon. Now, if volcanic activity still lingers on the Moon, this might have exciting implications for future lunar missions. In the coming decades, astronauts might be able to use volcanic heat for generating power, melting ice into water, or even warming bases built into the frigid lunar surface. But recent geological discoveries aren't limited to Earth's natural satellite. We learn more about volcanic moons beyond our solar system too. The detection of a possibly volcanic exomoon orbiting exoplanet WASP-49b around 635 light-years away means that volcanic activity may be a common feature among moons. Up until now, Jupiter's moon, Io, held the title of the most volcanic body we know about. But researchers at NASA's Jet Propulsion Laboratory may have found a new candidate. This potential exomoon came to light when scientists observed a cloud of sodium gas around the exoplanet. But the thing is, sodium clouds are unusual in planetary atmospheres and can suggest volcanic activity. The sodium cloud near WASP-49b had a bizarre, unexpected behavior. It was moving erratically, shifting size, and occupying a space too large to be explained by the exoplanet's own atmosphere. Scientists thought the cloud could actually be generated by a volcanically active exomoon in orbit around WASP-49b. Volcanic moons like Io are known to release gases such as sulfur dioxide, sodium, and potassium, which form massive clouds around their parent planets. Io, for instance, regularly produces vast amounts of gas that form a cloud encircling Jupiter, up to 1,000 times the size of the gas giant itself. If something similar occurs near WASP-49b, the gas cloud could be a clue to volcanic activity on an exomoon orbiting the planet. Observations from the European Southern Observatory's Very Large Telescope in Chile seems to confirm this theory. The sodium cloud around WASP-49b is positioned high above the exoplanet's atmosphere and behaves in ways that don't match the exoplanet's 2.8 Earth day orbit. This could suggest that it originates from a separate body, likely a volcanically active moon. Additionally, WASP-49b and its host star consist primarily of hydrogen and helium, which makes the sodium cloud even more unusual. The observed rate of sodium release, over 220,000 pounds per second, can be a sign of an immensely powerful volcanic source. If scientists verify the existence of this exomoon, it would be the first discovery of a volcanic exomoon. Back in our solar system, Io remains the main space object helping us understand volcanic moons. Recently, NASA's Juno spacecraft provided some of the closest images of Io since the Galileo mission over 25 years ago. Io's intense volcanic activity is caused by tidal heating, the result of the gravitational pull of Jupiter and nearby moons, like Europa. This tug-of-war generates immense friction within Io, producing heat that fuels continuous volcanic eruptions. One of Juno's most exciting recent findings was a new volcano that appeared just south of Io's equator. Juno's images show a large, complex volcanic region, approximately 111 by 111 miles in size. The craziest thing? It wasn't there when Galileo imaged the same spot in 1997. This new volcano formed near the previously known volcano Canehekele. Researchers say that this new volcanic structure is a great change that highlights the dynamic nature of Io's surface. Io's equatorial region is home to most of its volcanoes because of the concentrated tidal heating it experiences. The most powerful eruptions emit sulfurous gases and produce bright lava flows. They cover the moon in colorful, sulfur-rich deposits. JunoCam's image, taken from about 1,570 miles away, shows Io dramatically lit by sunlight reflected off Jupiter. And you can see a stunning view of its constantly changing volcanic surface. Despite these detailed observations, there are still many mysteries about Io's volcanism. Scientists are particularly curious about how tidal heating affects Io's interior, and whether it has a subsurface magma ocean. Plus, researchers try to understand what triggers different types of eruptions. For example, plumes versus lava flows, and how volcanic gases shape Io's surface and thin atmosphere. The study of volcanic moons from Io to the possible exomoon near WASP-49b sheds light on how tidal forces create volcanic activity in different moons. In icy moons like Europa, tidal heating sustains liquid oceans beneath the surface, creating potential habitats for life. But for Io without an ocean, the same forces instead generate powerful volcanic activity. Plus, if volcanic exomoons do exist, like the one possibly orbiting WASP-49b, we might soon discover more volcanic bodies across the galaxy.